Yeah.
Are we going to have like a test or a quiz on this? No.
There's a test on the entire chapter on Thursday. Okay, up here, please, everybody. Section 9. So remember that back in the day when we talked about inverse function, we said a function can have an inverse if it passes the horizontal line test. Okay, so it can have an inverse function if it passes the horizontal line test. So back then we said, remember we said this parabola as it stands did not pass the horizontal line test because it crosses, a horizontal line would cross it at two places. So what did we do? When we found the inverse function, do you remember we only found the inverse of 1/2 of it? Do you remember that we did that? So that's because in order for the function to have an inverse function, it should be able to pass the horizontal line test. So now if we take a look at a sine graph, right, which is like a wave that continues from negative infinity to positive infinity, does a sine graph pass the horizontal line test as it stands? Does it pass the horizontal line test? It does not, because if I drew a horizontal line through a sine graph, it would cross at how many points? Infinite points, right? Because it keeps going on and on and on and on and on and on. So what then? What are we supposed to do? Well, what we have to do is what we did, similar to what we did for the parabola, right? For the parabola, instead of taking the entire domain, we restricted it from 0 to positive infinity. And so that way it passed the horizontal line test. So what we do for the sine function is we cut down the domain. Instead of looking at the sine function from negative to positive infinity, we only take a small portion of it that would pass the horizontal line test. So for the sine graph specifically, so basically what we could do is I could just choose to take that much of it in the green, or I could just choose to take, that much of it in the green over there. What we've done, what mathematicians have done in order to form a consensus is they always like to go as close to the origin as possible. So very close to the origin, if I only take this portion of the sine function, does that blue one that I've highlighted, does that pass the horizontal line test? It does. So in order for us to fix that issue of it not being able to pass the horizontal line test, what we do is we take a portion of the sine graph, meaning we say we restrict the domain. And when we do that, this much of it is called the restricted sine function. All right? So this is the restricted sine function, as it says here. And so remember, the way we do it is we just restrict its domain. So now, what is the default period of the sine function? It goes from 0 to what? It goes from 0 to 2 pi. When we did this, okay, if this is pi, then what's this point here? Here, sorry, this one here. Here. Pi over 2. And this one to the left is negative pi over 2. So what we did is we just take the region from negative pi over 2 to pi over 2. So that's the restricted domain. And what's the range? It goes from what to what? From negative 1 to 1. So now the restricted domain here is negative pi over 2 to pi over 2. And then the range is negative 1 to 1. All right? So that's all that we're going to deal with. Okay? So now, So now, okay, so what's an inverse then? Do you remember the concept of an inverse? Way back when we talked about f of x and f inverse of x. How did we find f inverse from f of x? How did we find the inverse of a function? What's the first thing we did? You interchanged what? X and y. The first thing we did is we interchanged x and y. Remember, you swapped x and y. When we swapped x and y, what happened to the domain and range between the function and its inverse? It switched, right? So the domain and the range switched. So now, in my restricted f of x function, my domain is negative pi over 2 to pi over 2. Oh, I just realized this is in a different notation than what we're used to. So let me write it in our notation. So the domain is negative pi over 2 to pi over 2. And the range is negative 1 to 1. When we find f inverse, the domain and the range are going to switch. So the domain of f inverse is going to be negative 1 to 1. And the range is going to be negative pi over 2 to pi over 2. Okay. All right, so let's talk about what inverse sine is. So remember how for inverse we do to the power of negative 1? The inverse sine function looks like this. Inverse sine of x. Or arc sine of x. All right, so these are new words now. I can either write inverse sine of x or arc sine of x, and they mean the exact same thing. And that's the inverse of the sine function. So the way you would see it written is this. And we read that as y equals the inverse sine of x, or at x. Okay? All right. Let me go here for a minute. What does inverse sine mean? Okay, so do you remember how until now I would tell you sine of 60 degrees, and then you would say that that equals root 3 over 2, right? Now, we're going to go the opposite way. I'm going to tell you this, okay, is equal to, yeah, I'm going to give you the value. So I'm going to tell you this, and you're going to tell me the angle. So basically, I'm going to tell you what is this mystery angle for which the sine is root 3 over 2. And you say to yourself, okay, for what angle is the sine root 3 over 2? Is it 30 or 60? Oh, it's 60. So you say 60 degrees. All right, so I'm going to give you this, and you're going to give me that. All right? Okay, let's talk about some of the rules here. All right. Okay, so the questions are going to look like this. So for example, inverse sine of 1/2 is equal to some number y, right? That number y is always the angle. All right, so the answer that you're going to give me is the angle. This number here, that's our x. That number there must always be between -1 and 1. Okay? So now, here's what happens when we restrict the domain. Let's take a look at the unit circle. This is 0. Is that right? And what about up here? 90 or pi over 2, right? Okay. Now, if I go in the positive direction up, that's pi over 2. Now, if I go to the negative direction down, what's that? Negative pi over 2. Okay? When I'm talking about inverse sine of x, it's only this region that I'm talking about. Okay? So now, let's write some of the angles up here. The angle right in the middle is pi over 4. And this is pi over 6 and pi over 3, right? Okay, if I go down in the negatives, what are those angles here? Negative pi over 6, negative pi over 4, negative pi over 3. Okay? How many total angles do I have up here now? 1, 2, 3, 4, 5, 6, 7, 8, 9 total values, right? It's only these 9 angles that are going to be your answers for an inverse sine question. Okay, so if you have an inverse sine question, it's only going to be one of those 9 angles. So now, look at this for a minute. I know this is kind of confusing, but if we do a couple, you'll see what I'm talking about. Look at this. Look at what I'm given here. This number, right, that number x, so inverse sine of a number, inverse sine of a number, if that number is positive, the angle can only be in quadrant 1. All right, if x is positive, only in quadrant 1. If x is negative, only in quadrant 4. And again, it must be one of those angles. Yeah. So now, here is the question for you. All right, here's a question for you. Where is 7 pi over 4? What quadrant? 7 pi over 4 is in quadrant 4. But can that be an answer in a problem like this? No, because even though 7 pi over 4 is here, it's not one of these angles. So that can't be an answer. Okay, if you look at it here, right? This is pi, this is 2 pi. 7 pi over 4 is here. And that's not in your restricted domain, so it can't be an answer. So like Max was saying, the easy part of this is you only have 9 possibilities, so it's narrowed down for you. Your answer must be one of those 9. So really, whatever problem I give you for the sine, you have 1 in a 9th chance that you get it right. If you just guessed one of those angles, 1 in a 9th chance that you get it right. All right, so let's do a couple of examples. Okay, this one is telling me inverse sine of root 2 over 2. So here, the question is, for what angle is sine root 2 over 2? That's the angle. So what's the angle that you get root 2 over 2 for the sine? 45, or in radian? How much is it in radian? Right. Okay? All right, here. Inverse sine of root 3 over 2. For what angle? It's negative root 3 over 2. So what is the angle? It's got to be negative because it's got to be in this quadrant here. What's the angle that you get root 3 over 2? Is it pi over 6 or pi over 3? Pi over 3. So negative pi over 3. Okay, long side, big angle. Long side, big angle. For what angle? Okay, so now this is arc sine. Big deal, it's the same as inverse sine. For what angle is the sine equal to negative 1? Negative pi over 2. That's here. right? Negative 1 right there, so that's negative pi over 2. Okay? All right, so like that, I spend a lot of time on the sign because then the cosine and stuff are easier. We know now what it is. So like that, this is the cosine function. We have to do a restricted domain again. If I do negative pi over 2 to pi over 2, does that work? If I take this negative pi over 2 to pi over 2, would that have worked? Does that pass the horizontal line test? No. But this passes the horizontal line test. So now I have to take another portion, one that will pass. So from where to where do I go for this? 0 to pi. So I go from 0 to pi. So on the unit circle, I'm going to go from 0 to pi. This is pi over 2. So here I have pi over 3, pi over 4, pi over 6. And then what do I have here? What's the top one? Pi, how much is that? Here. Oh, wait. I did that wrong. I'm sorry. This is pi over 3 and pi over 6. I went backwards. So which one is this one here? 2 pi over 3, right? So now, this is pi over 4. How much is that one? How many pi over 4? 3 pi over 4. And how much is this one here? The green one? Pi over 6. How many? 5 pi over 6. Remember, it's the next one that doesn't cancel. Okay, this is the cosine. In the first quadrant, is cosine positive or negative? Positive. In the second quadrant, is cosine positive or negative? Negative. So, if x is positive, the angle can be in quadrant 1. If x is negative, it could be in quadrant 2. All right?
So for sine it's 1 and 4.
For sine it's 1 and 4.
And
Cosine is 1 and 2. Okay? All right, so let's take a look at these. Arc cosine, negative root 3 over 2. Which quadrant is it going to be in? 1 or 2? 2. Okay, so for what angle is the cosine root 3 over 2? Is it pi over 3 or pi over 6? Pi over 6. Okay, so for pi over 6, it's root 3 over 2. Because you have to go longer here, cosine, and shorter sine. So, if it's pi over 6 in the second quadrant, what pi over 6 is it? 5 pi over 6. Inverse cosine of 1. So the angle for which the cosine is 1. Positive 1. So it has to be x is 1, y is 0, so 0. Okay, here, inverse cosine of negative 2. Now this is my trick question. This is what I kind of said in the beginning, but we sort of let go. I said that this value here must always be between negative 1 and 1. So this one, yeah, where was it? This one, this is undefined because this is not between negative 1 and 1. Okay? All right, we never graphed tangent. And we're not going to in this class. If we had, it would look like arc just means inverse. So arc sine, inverse sine. Arc cosine, inverse cosine. If we had graph tangent, this is what it would have looked like. And the inverse would have looked like this. So all you have to care about this is, again, it goes from negative pi over 2 to pi over 2. Which one is that like, the sine or the cosine? That's like the sine, right? Except, this one's even better. because here when we go from, hey there, what a surprise. Well, you're more than welcome all the time to come see me. Do you guys know who this is? Oh, he's somebody's brother. Not that. Okay, so this is Hayden Cohn. He graduated. What year did you graduate?
17.
2017. How's it going? What's going on?
Well, pretty good. Decided to just say hi, my old high school.
Do you miss us?
I do.
Every day. Every day.
Yeah. What grade is this?
Every day. This is Algebra 2, so we're mixed. We have 9, 10, 11. We have everybody in here. And look, we're learning about inverse sine functions.
Goodbye. I love you, but I hated this lesson.
Well, you know, you just crushed my heart, but it's okay. It's okay. I'll forgive you this one time. I'll just take it out on your brother is all.
Thank you. And you know, I have another brother too. His name is Seth Kennedy.
I know.
Feel free to brutalize him.
No comment.
They're both smarter than me in math, so they'll probably do it.
No comment there either. Well, you were in my class.
Somehow.
It's always a pleasure seeing you. Bye, Hayden. Okay, so again, we're going to go from negative pi over 2 to pi over 2. So again, we've got these angles here, right? But guess what? I don't want to go into too much of the specifics, but you see how there are asymptotes for the tangent graph, which works out better for you guys because, so this so far, it looks very much like the sine, right? Except for the tangent, those are not a possibility. They're undefined at the pi over 2's. Okay, I know. So now you only have 7 versus the 9. Like, how cool is that? Yeah. So again, if it's positive, it's in the first quadrant. If it's negative, it's in the second quadrant. Exactly like the sine, except we throw away the plus and minus, the plus and minus pi over 2. So arctangent of 1 then? Where is tangent equal to 1? For what angle is tangent 1? So remember, tangent is opposite and adjacent, and the ratio has to be 1 for this angle. For what angle is the opposite and adjacent the same? Pi over 4. Okay, so for what angle is tangent root 3 over 3? Do you think it's the pi over 3 or the pi over 6? Okay, so for the pi over 4, right? What are these sides? Root 2 over 2 and root 2 over 2. Is that right?
No, it's either of those.
Well, I mean, I'm doing A again.
Oh.
So for pi over 4. And now the tangent, Andrew, is the sine divided by the cosine. And you see how that'll give us a 1. Okay, so here, why don't we try pi over 6, right? Now this is a half, and this is root 3 over 2. Does the sine over the cosine give us root 3 over 3? No. That gives me 1 over root 3. Does it not? What does it give me? Does it give me root 3 over 3? It does. Okay, so you just have to try it out. And I'll show you a little trick right now. So which one is this? Pi over 6. Okay, here we have inverse tangent of root 3. Which option will give us a root 3? Negative root 3. So will this be, so when you have a root 3, whether on the numerator or in the denominator, it's going to be either the pi over 6 or the pi over 3. So what do you think for this one? Is it the pi over 6? The pi over 6 was root 3 over 3, and this is a root 3. So it's the pi over 3. Okay? And then inverse tangent of 0. Where is tangent 0? Where is tangent 0? Where will y over x be 0? Where will sine over cosine here be 0? So what's this point here? 1 over 0. Is sine over cosine over there 0? Sine over cosine? Where's the sine here and where's the cosine? This is cosine. It's 0. So this is going to be 0. Okay. All right. Okay, so for this one, here's what we're going to do. It asks us, look at this one, for the tangent of the inverse cosine of 4 over 7. All right, you have an outside function and an inside function, right? So what we do is start with the inside and draw a triangle. Okay? Okay, we're going to draw a right triangle. And we're going to call one of the angles theta. Okay? Now, this is telling me, this inside, that there is this mystery angle, and the cosine of it is 4 over 7. What's cosine? Is it adjacent over hypotenuse? That means the adjacent over the hypotenuse is 4 over 7. Is that right? Now, the next step is going to be find the missing side. How are we going to find the missing side? Pythagorean theorem. So 4 squared plus x squared is equal to 7 squared. All right, so go ahead and find x for me. Oh, sorry. X is root 33. Okay, so now the third step is evaluate outside function. Outside. What's the outside function telling me? It's tangent of theta. So what's tangent of theta here? Root 33 over 4. Opposite over adjacent. All right? Okay, so now you, with the person you're sitting next to, if you're sitting in threes, you can work together. I want you to do B. Okay, so go ahead and do B. On your mark, get set, go. I have arc cosine of negative root 2 over 2. That's the same as inverse cosine. But what do I have in the front of it? Cosine. So I have cosine and inverse cosine. What those two do is they pretty much cancel each other out.
Oh, really?
Yeah, really. So here, this is just negative root 2 over 2. Okay? Because what you're doing here is, what is the angle for which you get negative root 2 over 2? Oh, negative pi over 4. What's the cosine of negative pi over 4? Oh, negative root 2 over 2. The only thing you have to be careful of is this number here is within our boundaries. So for example, if I had cosine of inverse cosine of, let's say, 3, why wouldn't that work? Right, this has to be between negative 1 and 1. Yeah, it would be undefined. Okay? This will be undefined. So that's the only thing. So what I'm saying is, don't just blindly go, oh, it's sine and inverse sine, I can just cancel them out. No, you have to make sure that this is acceptable. Okay?
What's the difference between arc cosine and inverse cosine?
They're the same thing. They're interchangeable. It's like if I said I was 17 or 16 plus 1 years old. Same thing. Okay? All right. Here we go. These you have to do with your calculator. So go ahead and take out your calculators. I know you've done this previously, so this is pretty much a review. What I want you to do is two things though. First, I need you to make sure that your calculators are in degree mode. Write the answer in degrees for me. And so first make sure that you're in degree mode and then write the answer in degrees for me. Okay. All right, so make sure, and also make sure you know how to go back and forth between radian and degrees.
I go 2 decimal places.
It says to the nearest 10th.
Right here, why is it not negative? Because you have the negative right here.
Oh, that should have been. Did we not say negative?
No.
Yeah, sorry.
So if there's a negative on the outside, it just means that the number is negative?
Yeah.
Okay.
No. Only for the tangent and the sine. So if it's a negative, you have to make sure it's in the proper quadrant. So for sine and tangent, it's in quadrant 4. But for cosine, it's in quadrant 2.
So what if it's negative on cosine?
Then you have to make sure that it's in quadrant 2. So it's somewhere, from 0 to, from like pi over 2 to pi. It has to be in quadrant 2. Okay, so how does that sound? What do you think? Like what we did today, does it sound like extremely confusing? How does it sound to you guys?
Just like remembering the rules.
Yeah, so remembering the rules, and it helps if you're very like comfortable and confident with your other stuff, right? Like the sine of pi over 2 and all that good stuff. Okay, now all of this will be on a non-calculator section on your test. So you have to make sure that well, I mean, except for this, right? But all the other stuff, they have to be on a non-calculator section. Okay, do we have anybody for the answers for these? Any volunteers to put them up for me? I need 2 volunteers. Yeah, that's it. That's it. So what do you guys have? How much? For the first one, is it 149.3? Oh, yes, it's cosine. So does that make sense that it's 149.3? What quadrant should it have been in? 2. So does that make sense that it's 149? Yes. Okay, so how about for the other one? That's it. The other one is how much? Yeah. Okay, one other thing I wanted to show you is for the case of the tangent, okay? What are the, okay, so our big angle and our small angle, right? Yeah. Yeah. I don't actually need the screen because I'm going to show you on the board. Just a sec. Okay, so our big angle and our small angle, right, for the pi over 3 and the pi over 6, right? I have a pi over 3 and a pi over 6. And again, which one of these is the small one? Okay, I haven't dismissed you guys yet, so don't play the just yet. Which one is the small one? Pi over 6. Okay, now, for tangents, when it comes to the 30s and the 60s, right, there are two possibilities. You either get a root 3 or a root 3 over 3 when it comes to the 30s or the 60s. So tangent is the ratio of the opposite, the vertical to the horizontal. Okay, it's just a ratio. Which one of these numbers is a bigger one? Root 3 or root 3 divided by 3? Root 3 is the bigger one, right? That's the ratio of the bigger side to the smaller side. So the big angle always gets the bigger tangent. The small angle always gets the small tangent. That's how you can tell. Okay? All right. What I want to do is, there is a handout, but I need somebody to go downstairs and pick up the handout very quickly. You can very quickly run downstairs to grab a handout for me. Anybody from Miss Faison? Nobody? No volunteers? That means you guys need to come one by one and grab that handout from me later on.